Good morning and afternoon, everyone. My name is Mohammad Abdullah, a student of BSSC 3B at Air University Islamabad campus. My registration ID is 232052, and I am presenting my 8th semester project Probability and Statistics course under the guidance of my esteemed teacher, Mr. Taishir. This project analyzes the hepatitis C dataset using various statistic tools. This presentation is titled Statistic Analysis of Hepatitis C Dataset. It aims to explore trends, calculate key statistics, and derive meaningful insight from the dataset. This project demonstrates the application of statistic method in the real-world context. Let's begin. The primary goal of this project is to analyze hepatitis C dataset and to identify trend and pattern. Our hypothesis is that certain liver enzyme levels such as ALT, AST vary significantly across the demographic group. The importance of this analysis lies in its ability to support better decision making in health related domains. Moving forward, dataset overview. The dataset contains 615 rows with both numerical and categorical attributes such as age, ALT, AST, gender, and category. To prepare for analysis, we address missing values through imputation and categorize the data into numerical and non-numerical columns. This ensures accurate and reliable analysis result. Now moving forward to next slide, frequency distribution. Frequency distribution were created for the both numerical and categorical data. For example, the age attribute showed that most participants fell within the 40 to 50 range, while the categorical data revealed that most participants were blood donor. This analysis also helped us to identify outlier in attributes like ALT and AST. Now, moving forward to data visualization, histogram. Histogram were used to visualize numerical data distribution. For instance, ALT level exhibit a right skewed distribution indicating the most participant had lower ALT values. Dynamic binding was applied to ensure clarity in these visualization. Moving forward to the most important slide, project scope. The project focused on analyzing the hepatitis C dataset to explore trends in liver enzyme level across different demographic groups like age and gender. We aim to uncover key insight through statistic analysis and data visualization, helping to understand pattern and variability in the dataset. However, the project does not include the predictive modeling, but instead emphasizes on exploring data analysis. Now, moving forward to measure of center tendency. Center tendency refers to the statistic measure like mean and median and mode. This that represent that center of a data set. For example, the mean ALT value was 28.4, slightly elevated due to outlier, while the median ALT value was 23. These measures provide a quick overview of data distribution. Now, moving forward, measure of dispersion. Dispersion measures such as range, interquartile range, standard deviation describe data variability. For instance, ALT level showed a wide range reflecting variability in enzyme level across participants. Box plots were used to visualize these measures effectively. Now moving forward to advanced visualization. We employed advanced technique like smoothened and commutative frequency polygons. Smoothened frequency polygons provided a continuous distributive view, while commutative polygons highlighted trends such as construction of ALT values below 30. Now moving forward to key findings. Yes, key findings. The analysis revealed that the database is skewed while notable outlier in the attribute like ALT. Most participants were aged 40 to 50. The data was predominantly main dominant. These findings emphasize the variability and trend in liver enzyme level among different demographics. Now I will show you the live demonstration of my stat and probability project. First, we will continue with my group dataset. Today, I will walk you through the group dataset analysis part of my stat and probability project, specifically focusing on how we can summarize, visualize, and interpret group dataset. Let's dive right in. First, let's understand the group dataset. Here, the data is organized into group or interval rather than individual data points. These intervals represent range. The frequency tells us how often data point fall within each range. Now, let's begin by calculating and plotting a histogram. A histogram is a graphical representation of our frequency distribution. It helps us visualize the distribution of data, how it can be spread across the interval. In the histogram, the data in x-axis represent the class interval and y-axis represent the frequency of data points within those intervals. Each bar, the histogram gives us a sense of how constructed or spread out the data is. Following the histogram, we will look into the frequency polygon. This is essential in graph. This is essential in the histogram. We will look at frequency polygon. This is essential in a line graph that can connect the midpoint of top and of the bars of the histogram. It helps us visualize trend in the distribution, such as whether the data is skewed or symmetric. One important visualization tool with group data set is cumulative frequency polygon. Cumulative frequency polygon help us understand the cumulative frequency across the interval by plotting the cumulative frequency on y-axis. Now, let's move to center tendency measure, the arithmetic mean, the most commonly used measure of measure tendency. We will calculate by taking the sum of the data set dividing into total number of data point and midpoint. Next, we will calculate median. The median is the middle value of the data set when arranged in the ascending order in the group data. We use median formula that incorporate in the cumulative frequency. Following the median, uh, following the median, we can complete the mode, which is the most frequency used value in the data set. For group data, we identify the model class, the interval with the highest frequency, use a formula to estimate the mode within that class. Let's finally touch the measure of dispersion, specifically the range and the standard deviation. Range is simply the difference of the maximum and minimum value in the data. It gives a quick sense and exception. With all this calculation, we can get a valuable insight into data such as spread, central tendency, and overall shape of distribution. That concludes the demonstration of how we handle and analyze group data. These steps are from the core of understanding and distribution, central tendencies and spread of data, which are essential for making informed decision in any statistic analytic. Hello everyone. In this part of the project, I focus on analyzing ungrouped data from the hepatitis C dataset. My primary goal was to clean the dataset by addressing missing values, filling numerical columns with zeros, ensuring accuracy in further analysis. Next, I categorize the data into numerical and non-numerical columns for targeted visualization and analysis. For numerical data, I created histogram and smooth frequency polygon to observe distribution pattern, while bar chart were used for categorical data to represent frequency trend. These visuals were enhanced with refined aesthetic such as smooth curve, shaded region, detailed labeling to make the insight both visually appealing and easy to interpret. I also developed cumulative frequency polygon for numerical data. I calculated cumulative counts using categorized bin and plotting midpoint to create an accurate representation. Similarly, for categorical data, I calculated and plotted cumulative frequency for unique values, offering a clear window of progression. Overall, this implementation provided a comprehensive and visually engaging way to understand and ungroup data pattern and enabling more detail. Now, let's conclude this presentation. In conclusion, statistic tool allowed us to effectively summarize and visualize the dataset. ALT variable can guide medical assessment. Future analysis could explore correlation and predictive modeling for health outcome. Limitation like small sample size and missing data highlight areas for improvement in the future project. Now, in the end, I want to thank you all for your time and attention. I hope this presentation has given you a clear understanding of how statistically analysis and reveal important insight from the hepatitis C dataset and contribute to better health decision. Thank you. Allah Hafiz.